Today we're going to talk about uniform accelerated motion. Uniform accelerated motion will occur in situations where you have a constant but unbalanced force set, system. In those situations, the acceleration will be uniform, which does not mean everything else will be constant. Speeds, if you have an acceleration, will therefore be changing. It'll either be speeding up or slowing down, but it'll be doing so at a constant rate. If you want to look at this type of motions, there's a few variables we can examine. First, distance. Distance will tell us how far the object is moved while accelerated. Time. How long will the object be moving at an accelerated rate? Final velocity. The velocity after which the acceleration has occurred that you can attain. Final velocity. Initial velocity. The velocity from which you accelerated. And finally, acceleration. Okay. Now the acceleration is defined as the change in velocity over time. And if we look at change in velocity with respect to a final and initial velocity, then that is really the difference between the change, the final and initial velocities, divided by the time. So acceleration then is this change in velocity over time, which gives us that equation. Okay, now for acceleration. There are a few other equations that also use acceleration and deal with all these other variables. Okay, let's put them up. Those equations will be distance is equal to v naught times t plus at squared over 2. Vf squared is equal to v naught squared plus 2ad. Vf is equal to v naught plus at. Now this equation is actually the equation that I had originally put up. It's just manipulated. That is the same as, right? These two equations are identical, just different forms of the same equation. And finally, okay, so this last equation, the average velocity, we haven't much talked about, but it stands to reason that if you are accelerating at a constant rate, that you will have an average speed, and you simply need to take your final and your initial speeds, add them together, and divide by 2. That'll give you an average. Okay, so these are the equations then that can be used when you have a uniformly accelerating object. That is, that the acceleration is uniform and constant, but the velocity may not be. All right, here's a typical question that involves accelerated motion. Now there's a few clues in the question that indicate that it is in fact an accelerated motion question. First one is right here, from 5 meters per second. That indicates that it starts at 5 meters per second, and that there's going to be some change in the speed, which indicates an acceleration. Secondly, it says it's going 5 meters per second, and it mentions a time of 10 seconds. If you go 5 meters per second for 10 seconds, we would expect to cover a distance of 50 meters. But in fact, this object covers a distance of 150 meters. So, clearly Mr. Physics Ferrari is accelerated. Now, first thing we do to approach these types of questions, or any kind of question for that matter, is pull from the question the numbers and the variables that those numbers represent. So 5 meters per second, that's going to be an initial velocity. I know it's initial because of the from. V naught is equal to 5. I know that the distance traveled here is going to be 150 meters. And I know that the time to travel that distance is 10 seconds. Now, we need to select an equation that uses these three variables, and we'll answer one of our questions. We're looking for, to what velocity does he accelerate? That's got to be final velocity. And what was his average speed, or VAV? All right, let's look at our variables, and let's look at the equations we have available to us in kinetics. These are the equations we have to deal with in kinetics. We're looking for final velocity. You might think that we're going to use one of these two equations. They're really the same equation. We have V naught. We have T. But we don't have A. So the use of this equation would not be possible because there's two unknowns. The same is true for this equation, which also has VF in it, the variable we're trying to find. We have V naught. We have D, but we again don't have A. So that's not useful for us. Unfortunately, what we're going to have to do is use this equation, even though it doesn't include the variable we're trying to solve for. We have V naught, we have D, and we have T. We can use this equation and solve for A. Once we have A, then we can turn our attention to one of these two equations and solve for VF. Now that we've selected an equation, given that we have V naught, D, and T, the only equation we can use is distance is equal to V naught T plus AT squared over 2. Now this isn't going to solve for our desired variable immediately. It's just the only equation we can use. We can use it to calculate acceleration. We can then use that acceleration to solve for the variable we're interested in. Let's substitute. For distance, 150 meters. For initial velocity, 5. For time is 10. Find the acceleration. Okay, I'm going to pull out a trusty calculator. 150, 5 times 10 is 50, minus 50, times that by 2, and divide by 10 squared, or 100. That's going to give me an acceleration of 2 meters per second squared. Okay, now that I know the acceleration, I can make use of that to find final velocity. And there are two equations that will solve for final velocity for us. VF is equal to V naught plus AT, or VF squared is equal to V naught squared plus 2AD. I'm going to choose the first one simply because it's shorter and easier. Initial velocity 5. Acceleration is 2. Time is 10. Oh, actually. There we go. Okay, 2 times 10, that's going to be 20 plus the 5, 25 rounded to 3 sig figs. There's our final velocity. Now we need to solve for average speed. There's a couple of ways we can solve for average speed. One of the ways to get average speed from an accelerated motion question is to do this. Average speed will always equal the total distance traveled by the time it takes to travel. Okay? That will be 150 meters divided by 10 seconds. And that's going to give me 15 meters per second. Of course, the other way to find average speed, since we know final velocity and we know initial velocity, would be to simply find the average between those two numbers. Add the final and the initial speeds and divide by 2. So, of course, the final is 25, the initial was 5, 25 plus 5 is 30, divided by 2 is 15. So both methods would get us to the same answer. So when you're doing questions in accelerated motion, it will be sometimes necessary to solve for values which the question does not ask for, so that you have the information that allows you to solve for values which the question does ask for.